Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to see what is dilution formula and how do we perform serial dilution. So let us first try to understand what is the meaning of a concentrated solution and a dilute solution. So what is the meaning of concentrated solution? In a concentrated solution, as you can see in this image, there are more solute particles, which means more solute is added to the solvent to prepare this solution. And another way of looking at a concentrated solution or identifying a concentrated solution is it is its color intensity. Okay, a darker color means it is a concentrated solution. A more concentrated solution, as you can see here, it is brown colored solution, which means it is more concentrated or concentrated solution. And then when we add water to this solution, that is when we perform dilution, what will happen is the color will fade out, or it will become a light intensity color, or it will become a light color. So here the color transformation after dilution took place from brown to here it became an orange color, a light orange color. And here in this image you can see that there are only few solute particles as compared to the concentrated solution. So this is what is nothing but called as dilution, that is we add more amount of solvent or excess solvent to prepare a dilute solution. Now this amount that we prepare, it has to be fixed. Suppose I want let's say I want 0.5 molar solution, I have to prepare from, let's say, 1 molar of solution. Then I have to use a fixed amount of volume. I cannot randomly add any amount of volume. So that is what we have to see. So initially there is a stock solution. What is a stock solution? It is a solution of higher concentration. Okay, it is already prepared. Let's say this is 1 molar of KMNO4 solution. Okay, this is purple colored solution. This is KMNO4. Suppose this is 1 molar or molarity is 1 molar. So what we do, we take some amount of this stock solution, and then this is what is we are going to prepare is the new dilute solution. Okay, this is how we take a small amount and then we will add the solvent up to the mark. So what is serial dilution? Serial dilution is that first, let's say this was our stock solution. From this you take some ml, let's say V1. Okay, let's say this flask is A, the second solution is B, C and D. So what we do, we take some amount of volume from VA and we add it to second flask, that is VB, and we dilute it up to the mark. Okay, this is the mark, that is up to the, this is the meniscus. And for colored solution we have to see the upper meniscus. There is this upper meniscus and lower meniscus. Upper meniscus we have to see for colored solutions, and for the colorless solution we have to use the lower meniscus. We have to fill up to the lower meniscus. This is the upper meniscus. And for colorless solution we have to fill up to the lower meniscus. Okay, so I took some amount of stock solution, that is VA, and I added to this flask, that is B, and then I add solvent up to the mark, up to the upper meniscus, because it is a colored solution. Then I take some amount from this VB, from this B flask, that is VB, and then I make the C solution. Similarly, from C solution I take some amount, let's say VC, and I make our solution D, which is the last one. So in this way, this is called as, this is we are preparing a series of solution, right? We are taking the solution from from the first stock solution, then we took from the flask B, then from the C, and then we prepare the final solution D. That is, we are preparing a series of solution with different concentration or lower concentration. That is why this is called as serial means we are preparing a series of solution, and eventually what we are doing is we are performing dilution in each case. That is why this is called as serial dilution. Okay, so now let us see what is the dilution formula or formula that we have to use for performing this dilution or serial dilution. So one thing that we have to remember is when we perform a dilution, a process of dilution, what happens is the moles of a substance remains the same. Okay, moles of the solution remains the same. Why? Because we are not adding any excess amount of KMnO4, solid KMnO4, neither we are adding, we cannot remove obviously, but we are not adding any excess KMnO4 compound, that is solid compound, we are not adding in the solution. So the moles of the solution will remain the same. What we do in the case of dilution, we are just adding solvent. Okay, we are just adding solvent. So what is the criteria? That is, moles before the dilution will remain same as that of the moles after dilution. Okay, this is the formula. MIVI is equal to MFVF. We can also write, in some books it is written as M1V1 is equal to M2V2. It is one and the same. What is MI? MI is the initial molarity of the solution. That is, let's say we start from the stock solution. So this is the molarity of stock solution. It was 1 molar, right? And Vi is the volume that we have to take from the stock solution. That is what we have to calculate. And what is MF? MF is the final molarity of the next flask or next solution that we have to prepare. Okay, it is the molarity of the solution that we have to prepare, and how much volume we have to prepare, that is nothing but Vf. Okay, so Mi can also be written as M1. Initial volume is V1, final molarity is M2, and final volume is V2. Okay, so now let us try to understand how do we get this formula. So molarity is moles of solute divided by volume of solution in liter. So what will be moles? Moles is nothing but we will do cross multiplication. Molarity into volume. That is how we get Mi into Vi, that is initial moles will be initial molarity into initial volume. What will be final moles? It will be final molarity or the concentration that we require into the final volume. Okay, so now let us do an activity so that we can easily understand this concept. So question is given, we have to prepare 3 solutions of 100 ml, that is 0.5 molar concentration, 0.25 molar concentration and 0.125 molar concentrations of NaOH, that is sodium hydroxide. What is the stock solution? Stock solution given is 1 molar NaOH. Okay, so let us first MIVI is equal to MF into VF. So first we have to see how much stock solution we will require. That is Vi, that is the initial volume of the stock solution that we have to calculate. So MF into VF divided by Mi. So what is the final molarity we require? First we are preparing 0.5 molar solution. Okay, 100 ml of 0.5 molar solution. Which solution we are preparing? 100 ml of 0.5 molar solution. So what is the final molarity that we require? 0.5 molar into what is the final volume of the solution that we require? We require 100 ml solution divided by what was the initial molarity? 1 molar. So here molar and molar gets cancelled. 0.5 into 50, 0.5 into 100 is how much? 50 ml. Okay, so what we require is to prepare 100 ml of 0.5 molar NaOH solution. We require how much? We require 50 ml of the stock solution. We require 50 ml of 1 molar NaOH. Okay, in this way we can prepare 0.5 molar concentration solution. And now let us see the other solution. Second, we have to prepare 100 ml of 0.25 molar solution. So again we use the same formula, MIVI is equal to MFVF. We have to calculate how much volume of 0.5 molar solution is required. Final molarity that we require is 0.25 molar into what is the final volume that we require, 100 ml, divided by which concentration now we will take. Now we will take the next concentration that we have prepared in the first step, that is 0.5 molar. So if we solve this, molar and molar will get cancelled. 0.5 into 2 will be 0.25 into 2 is 0.5. 100 divided by 2 is 50 ml. So again we will take 50 ml from the 0.5 molar concentration solution, that is we require, okay, here I will write, to prepare 100 ml of 0.25 molar solution, we require how much volume? 50 ml of 0.5 molar solution. Okay, so now we have to see the last one, that is we have to prepare 100 ml of 0.125 molar solution. So again MIVI is equal to MFVF. So VI is equal to, final molarity we require is 0.125 into final volume is 100 ml. Okay, this is molar, divided by, now we will take 0.25 molar solution. Okay, so again here molar and molar gets cancelled, we will get the answer in milliliters. So again here 0.25 into 2 is 0.125 into 2 is 0.25. So 100 by 2 is 50 ml. So for this solution also, that is to prepare 100 ml of 0.125 molar solution, we require how much ml? 50 ml of which solution? 0.25 molar solution. Okay, so we got all the answers. Now let us try to summarize all of them in this diagram. So initially we had this stock solution. A stock solution, what was the concentration? It was 1 molar NaOH solution. Okay, so what we have to do? We have to take how much ml of this? What was the first answer? 50 ml, right? So to prepare the first solution, dilute solution, that is we have to prepare 100 ml of 0.5 molar solution. We will take 50 ml from the stock solution, and then we will dilute it up to the mark, that is the upper meniscus, with the water. Next solution that we have to prepare is 100 ml of 0.25 molar solution. So how much ml we will take? Again we will take 50 ml from this second flask, that is 0.5 molar solution. Okay, and then we will dilute it up to the mark, we will get our 0.25 molar solution. And then for the final solution, again we take 50 ml of this second solution, that is 0.25 molar, and we will get 100 ml of 0.125 molar of NaOH. So in this way we have to perform the serial dilution by using the dilution formula. I hope you understood. Thank you.